So I spun the spinner, landed on red 3 times, blue 4 times, and green 3 times. What is the theoretical probability of landing on blue? Well, remember, when it comes to theoretical, I do not use this information at all. I just look at the table, and in theory, I should land on it 3 out of the total amount of times, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So that's 3 out of 12. That means 1/4 of the time I should be landing on blue. Should. Now, when I actually did the experimental theoretical probability, I landed on blue 4 times, and that's 4 out of the total 10 that I spun. So that's 4 out of 10. That simplifies to 2/5. Two different answers because there's two different types of probability. Theoretical, meaning in theory, just look at the picture. Experimental is when I actually did the experiment. I don't need to know what the spinner looks like. Now today we're learning about independent versus dependent, which is totally different than theoretical versus experimental. You must know the difference between both sets of information. Okay, so now let's look at the difference between independent and dependent. An independent event is when the occurrence of one event does not affect the probability of the other. It is independent of itself. That's because the outcomes cannot change. If I flip a coin, I always have heads or tails. It's never going to change. The results do not affect the other outcomes. So if I roll a dice, it always has 6 sides. It's never going to have 5 or 4. It's not going to be affected. A dependent event, on the other hand, is an occurrence of one event does affect the probability of the other. So think about cards. If I start with a deck of 52 cards, I pull one out and keep it out. Very important. I keep it out. The probability of getting the next card changes. So the first card I pulled is actually going to affect the second card I pull. So for the second event, I now have only 51 outcomes left in the deck because one is pulled and remaining out. Okay, so the directions determine if an event is independent or dependent. Independent mean one outcome does not change. The first outcome does not affect the second outcome. Dependent means they are affected. One depends on the other. So number 1, a coin lands heads on one toss and tails on another toss. Well, as you know, this is a coin. There's only 2 outcomes. That is never going to change. Okay, the second one, draw 2 blue marbles from a bag, not replace it, then draw a red marble. The important part is not replacing it. See, since it's not going back in the bag, the outcomes are going to change. So if there's 12 marbles, it's then becoming 11 marbles left in the bag. There's only 11 outcomes then left. Okay, so think about what you've learned about probability so far. What's the probability of spinning a 1? Well, if we look at this spinner, this is 1 here out of a total of 8 slices of pie. So to spin a 1, that is 2 out of 8. But new information is we're going to spin it 3 times this time. So what you need to remember is probability, only operation is multiple choice. So remember that. 2/3 spinning once, 2/8 of spinning again, and a third time, 2/8. Because I'm going to spin once, probability of landing on 1 is 2/8. Spin again, it's still 2/8. Spin again, it is still 2/8 chance of landing on those ones. Now we just have to learn how to solve. In order to solve, remember to simplify. 1/4 times 1/4 times 1/4. Now multiplication is done straight across. So 1 times 1 is 1, times 1 is 1 again. So that's 1 on top. 4 times 4 is 16. 16 times 4, you go off. If you need to remember 16 times 4, you do the math, and that is 64. So that is a 1 in 64th chance of spinning a 1 3 times. Now this is the first time we've done this, so pay attention again. I've spun the 1. The probability of spinning the 1 is 2 out of 8. That's this one spin. To spin it again, 2 out of 3. Or 2 out of 8. To spin it again, 2 out of 8. That is 3 different spins. So 1 spin, 2 spin, 3 spins. Each spin is a separate fraction, and then you multiply straight across. You could simplify before or after. The final result needs to be 1 out of 64 spins. Okay, so now that we've learned that, let's practice again. What's the probability of spinning an odd number all 3 times? So again, we're going to have 3 different fractions because I'm spinning 3 times. So let's figure out odds. Odds, 1, 3, 3, 1, 3. That is 1, 2, 3, 4, 5. 5 out of the 8 times of getting an odd. Spin it again, it's still 5 of 8. Spin again, that's still 5 out of 8 because these are all independent events. Now, I can't simplify those, so I just go ahead and multiply straight across. 5 times 5 is 25. 25 times 5 again gets you 125 on top. 8 times 8 is 64. 64 times 8 gets you that number on bottom. So let's do the math. 64 times 8, that's a 32. 48 plus 3 more is 51. That's 512. Okay, so now to go over it again. To get your final answer of 125 over 512, you multiplied your numerators, 5 times 5 times 5 again, and you got 125. You multiplied your denominators, 8 times 8 gets 64, times 8 again, and you get 512. It cannot be simplified, so it is just your final answer. Okay, so now we're dealing with cards. With cards, you have to remember these can be independent or dependent, whether it's getting replaced or not, whether the amount of outcomes is changing. 52 cards in a deck. If you take one out and you remain out, there's only 51 left in. In this case, it's not replacing it. So this is a dependent event. Very, very important. Write it, dependent event. So the probability of pulling a king, think about this, there are 4 out of 52, put parentheses around it because that means multiplication, kings in a deck. I'm not replacing it. So I know the next fraction, I'm only going to have 51 cards left in there because there's only 51. One of those kings is now gone. But there are still 4 jacks. So that's 4 out of 51. Okay, that is just 2 pulls, 1 king and 1 jack. So that is 1 pull and another pull. That's 2 separate fractions. Now, if you could simplify, it makes it easier because you're not multiplying larger numbers. Doesn't matter if you do it before or after. I'm going to go ahead and simplify this because I know that is 1/13 because that homework we did when we were simplifying them all. 1/13. I know the only thing that goes into a 51 is a 3. 3 does not go into a 4. So that one cannot be simplified. So now, that's just simplifying. We still have to do the operation of multiplying across. So let's go ahead and multiply across. 1 times 4 is 4, so my numerator is 4. 13 times 51. I got to go ahead and do that math. 51, 13. 1 times 13 is 13. Now remember that's a placeholder on that second one. That's 0. 5 times 3 is 15. 5 times 1 is 5, plus 1 is 6. That's 3, 6, 6. That's 663. And that is your final answer. 4 over 663 chances that you would pull a king, not replace it, keep that king out, and then draw a jack, the second pull. Okay, so now we have marbles. Now marbles, remember, you could take something out and leave it out, or you could put it back in. So think about this. We have to read it very carefully. And it says without replacement, meaning I'm leaving it out. So this is, again, a dependent event, meaning that denominator is going to change on my fractions. So the first thing I want to do is make a list of what's the contents of this bag. You have 3 different types of marbles. We have black marbles, which there are 2. You have white marbles, in which there are 4, and striped marbles, in which there are also 4. Very important part, get that total, and the total is 10. Just like in a deck of cards, we got to know the 52 before we begin. So there are 10 whole marbles in this bag. Let's go ahead and find our probability. They want the probability of drawing 2 stripes. So we're looking at stripes. The first time I pull, there is a 4 out of 10 chance. The second time, I'm going to go ahead and mark one of these stripes off and mark it off my total also, because I'm not replacing it. My totals have changed now. It's not in the bag anymore. So with the second pull, it's second stripe. There would only be 3 stripes left in the bag and a total of 9. So there's 2 different pulls. That means 2 different fractions. I'm going to go ahead and simplify them first before I multiply across. I know this can both be divided by 2, so that is 2/5, parentheses around it. I can simplify this. 3 goes into both. I know that is 1/3. Now I'm going to multiply across for that final answer. 1 times 2 is 2. 5 times 3 is 15. And that's my final answer. Since I already simplified here, I know my final answer is good. And that is 2 out of 15 chances to pull 2 stripes from the bag without replacing. This is also when I pull 2 stripes if I pull 2 marbles at the same time. Okay, so think about it, independent or dependent event. We're talking about a jar, so it could be both because I can pull stuff out. A jar consists of 16 quarters and 10 nickels. If 2 coins are randomly chosen, what is the probability of getting 2 quarters? Well, in here I have 16 quarters and I have 10 nickels, and that's a total of 26. Now when it comes to randomly choosing 2 coins, that you're assuming you're choosing 2 at the same time. So think about it. I'm holding 2 coins in my hand. So this is a dependent, write it down, event, because I can't hold 2 of the same coin in my hand. So I can't hold 2 of the same exact coin in my hand. So here we go. Let's figure out our 2 fractions. First off, we're looking for a probability of 2 quarters. That is 16 out of 26. So 16 over 26 is the first one. And since it is dependent, I'm going to knock one of these quarters out because one of them is already in my hand and only 25 left over. So that's 15 out of 25 now because they're both quarters. Okay, so 2 coins, that means I have 2 fractions. I'm going to go ahead and simplify them before I multiply across. I know those are both even numbers, so I'm going to divide them by 2, and I get 8 out of 13. And then I know these are both ends in 5s, so I know I could divide them by 5, and then I get 3/5. Now I just got to do that math of multiplying straight across. 8 times 3 is 24, and 5 times 13 is 65. So our final answer is 24 out of 65 chances of pulling 2 quarters. Okay, please make sure you know your standard deck of cards. You need to know this. It is common knowledge. You need to know that there is 2, 3, 4, 5, 6, all the way through 10s. The 11 is a jack. The 12 is the queen. The 13 is the king. And of course, there's always the ace, which can be the highest card or the lowest card of a 1. And there's 4 of each type.